Can you describe to me the current process of Neuralink? What are some of the situations that it's currently used, and what can it currently do? Here's where Neuralink stands as of early to mid 2026. The core product is active use. The core product in active use is called telepathy, a brain-computer interface built around the N1 implant. It's designed to record and decode movement-related signals from the motor cortex. So, from my understanding, like when I was in university, they had this thing where you could put on your head and you could read your brain signals. Um, and that time they were just playing around with if you think really hard about something, you can get a certain brain signal, and then you could use that brain signal in the machine to cause a movement. Uh, that was like the initial steps to this. Obviously, once you're implanting it, you can read much more delicate signals and much more precisely. Like, I think back when I was in university, they had a product where if you moved your head, it would read your brain signals and it would like move an arm or something. But it needed like significant movements and stuff. Come a long way from that. It's designed to record and decode movement-related signals from the motor cortex. It's like at the back of the spine. Maybe this isn't even a brain implant. Maybe this is like a spine implant. Motor cortex. No, that's brain. Motor cortex is part of your brain. So then do you implant this under the skull? That is certainly what it looks like they do. Just drill a tiny hole in your skull. Okay, I mean, I would probably never do that, but the implant is a small coin-sized device with very thin, flexible threads carrying over 1,000 electrodes. So instead, before you were reading full brain patterns, now they know the exact spot on the brain to put the device in order to read all the signals that you need. These threads are surgically inserted into the cerebral cortex using a specialized robotic system called the R1 robot to record and stimulate neural activity with minimal tissue damage. The electrodes, I mean, like, you cut open the skull and minimal damage is only so minimal. Something tells me no matter what, it takes a long time to recover from. The electrodes pick up the firing pattern of neurons involved in intended movement, and decoding software translate those signals into actions on a screen or device. So the thing that's difficult here is that things are not the same for everyone. When you're looking at like brain patterns, there's similarities, but kind of like a fingerprint, everyone is a little bit different. And so the issue, as much as it's difficult to like read the signals, it's also difficult to decode the signals, because the specific decoding is going to be a little bit different for everyone. And maybe this is where AI can help, but adjusting the decoding to match your specific signals is what is the difference between a failed product and an effective product in this kind of area. The whole thing is wireless and rechargeable. you gotta like stick a battery to the top of your head to charge. I'm saying this as a joke, but this is probably also what they do. Like they probably put it in a headset that you got to put on, but it's like a battery in the thing in your head. Kind of like how you can put your phone on a wireless charger. You got to put the wireless charger to your brain. So there are no wires coming out of the head. I mean, that is a problem you do have to fix. On scale and the people using it. As of late January 2026, Neuralink said it had 21 total participants enrolled in trials worldwide, up from the 12 reported in September 2025. I expect this will go up massively pretty quickly. As the capacities of Neuralink expand, you're gonna get a lot more people that like we're gonna see it fixing like disabilities, because those are the people most likely to allow a robot to cut a hole in their head and put a little chip in there. But as its capacities expand, you will get more and more people that'll do it. The first human implanted was in January 2024 in Norland Ogburn, a quadriplegic man. The company reports a record of 0 serious device-related adverse events, though that's their own characterization. And long-term independent safety data is still accumulating. Enrollment is currently limited to people with serious motor impairment, quadriplegic from spinal cord injuries, ALS, or brainstem stroke. It is still an investigatory words, early feasibility study, and not an approved commercial product. What it can do today, demonstrated by real participants. The first patents has used it to play the first patient has used it to play video games, browse the internet, post on social media, and move a cursor on a laptop, all through thought alone. Participants have used 3D Divine software and played games like chess and Mario Kart. In a separate strand of work, participants have started learning to move a robotic arm using only brain signals, controlling its position, gestures, and even precision grip. This is the thing, right? The first iterations are obviously always the worst, and this is an area I expect to see great advancement in a short period of time. The amount of money, like I think AI is actually hurting a lot of other areas of development that could be very profitable and beneficial to humanity. And this is one of the areas I think should be getting a lot more money that isn't. Using it with AI to like specifically decode. The issue is that everyone, as I brought up earlier, everyone's brain's a little different, kind of like a fingerprint. But if you can use an AI and allow them to essentially learn allow the system to learn what you mean when you think something, with feedback, then you can create a system that can decode much better. And with that, you could see much more adoption once this improves, because that would lead to rapid improvement in the system. And with rapid improvement, you would see rapid adoption, in my opinion. Robotic arm work is a second study, the Convoy study, running alongside the main cursor control trial, Prime. It investigates neural control of assistive robotic arms with goals like picking up objects, heating food, drinking from cups, eating, operating wheelchairs, and controlling smartphone devices using thought, essentially restoring physical independence rather than just digital interaction. Geography isn't expanded beyond the US. Neuralink announced its first UK participant in October 2025. Relevant to you in Alberta, Neuralink Patient Registry is now accepting applications from Canadian residents to assess primary eligibility for future clinical trials in Canada. Oh, that's interesting. I mean, you still probably have to have a severe disability, but sounds like Canadians will get a chance to get a chip put in their brain. A few things worth flagging as not real yet, since you get a lot of breathless coverage. Blind sight, separate implant meant to restore vision by stimulating the visual cortex, received an FDA breakthrough device designation in June 2025 and has had human trials targeted for 2026. But as far as the reliable reporting goes, it hasn't been implanted in a person yet. Claims you'll see about superhuman vision, impaired perception, intelligent enhancements, or AI symbiotic come largely from Musk's public statements and promotional blogs, not from demonstrated results. For commercial availability, analysts anticipate a first release for paralysis patients around 2028 and further trial phases and regulatory approval. So the honest summary, today Neuralink's reliability restores digital control, cursor, computer games, communications for a small number of people with severe paralysis, and is in early stages of extending that to physical robotic control, vision restoration, and the more sci-fi cognitive claims remain aspirational rather than currently capacities. One note on sources, Neuralink milestone have heavy self-reported and surrounded by a lot of hype-driven coverage. So the figures above lean on Reuters, the company's own updates, and clinicaltrial.gov rather than the boasters' blogs. The boosters blogs. If you want, I can dig into it. No, let's have a look at a couple of videos.
We're starting off with
about what it can actually do.
With reducing human suffering. Our first product is called telepathy, and that enables.
I mean, I'm stopping it instantly. Look at that. So these are the nodes that'll read brain signals. And so did these each individually have to be put in the exact right position? Or do you just put them on there and then you get the full reading and you decode that reading? And a lot of the interpretation is done externally rather than needing to be incredibly precise internally. That would make more sense.
Empathy, and that enables someone who lost the ability to command their body to be able to communicate with a computer.
I'm thinking and a cursor is moving on a screen. It blew my mind. It's not a matter.
I mean, like, this is not a large step. We have had the ability to, like I said, when I was going through university, we had nodes you could put on your head and it could read brain signals, and then you can create a computer to interpret the brain signals. It wasn't very delicate, and like moving a cursor, probably not possible. Like, what do you get them to think to move the cursor? They've reduced noise by obviously implanting directly into the brain. You don't have the skull and hair and everything in the way, so you can get a much better signal, and then made it easier to interpret. I still think the make or break for this is going to be in the decoding. How do you decode the signal from the brain. That is where I imagine is the difference with Neuralink compared to the old technology I've seen.
If I can do something, but like how?
It's been nothing short of miraculous. Before the implant, I was locked in, nonverbal, quadriplegic. Now I control my computer just by thinking, and the rewards have been immense for me.
ALS hits you like a pound of bricks. I am not able to do things that other dads can, but now he thinks it's so cool that I can do things that other dads cannot.
It's great to control a computer. That's a huge step. The Convoy team is the team at Neuralink that's working on assistive robotic devices controlled by the brain implant, physical independence in the real world.
I was moving the different directions and the different axes with, I don't know, it's pretty incredible just to think about. It's a really good feeling.
The thing is, this is incredibly valuable data. Like, putting this work in and getting this data, AI is very good at data analysis and data interpretation. If you get enough of this data, you can make it better, and you can make it faster, and you can make the decoding and individualization of it faster. Because a lot of the problems you run into here is that when
It's a really good feeling.
when you're
seeing
controlling an
what
arm
the-
like this, all the data is very specific to this individual, and trying to relate that data to another individual who gets it is actually like, you don't want them starting at zero again to train. You need them to like start off where this left off, but with how brain signals work, and that's difficult. I think AI could assist there. Anyway, let's continue.
It's capable of.
I'm going on a
It
tangent.
was incredible to be able to just gesture with an arm again, gaining functionality that I thought was gone forever was so incredibly life-changing.
Like most ALS patients, Kenneth was losing his ability to speak. The real value of the brain-computer interface is that it would give Kenneth his voice back.
There we go.
I'm talking to you with my mind.
Everyone gets his own color.
Will be blue.
You're gonna do that?
Yes, please. I'm done with my turn.
Our next product is Blind Sight, which will enable those who have total loss of vision, including if they've lost their eyes or the optic nerve,
Oh, so the blind sight's done by them.
to be able to see again.
The future of this technology feels almost unlimited. We're
Yes,
going to continue
I agree.
advancing the quality of the sensors, the number of the sensors. Surgery will advance, robotics is going to advance, and we are finding ways to apply it across all regions of the brain as we find new ways to refine and enhance its capabilities. It really feels like the sky's the limit for what we can do to help.
How's it feel, Audrey?
Life-changing. Life-changing. I could not ask for more. All with my mind. All with my mind.
That's incredible. Like, this is incredible technology, and I do believe that the future of it is limitless. Watch one more. on this part of
There
this.
we go.
I'm talking to you with my mind.
Lose the ability to speak as the disease
We're starting off with
progresses.
reducing human suffering. Our first product is called telepathy, and that enables someone who has lost the ability to command their body to be able to communicate with a computer, and the ability to do conceptual, consensual telepathy.
In January of 2026, Ken became the second participant to receive a Neuralink implant.
This is so new, right? January of this year, we're looking at 5 months ago.
For voice. He will be able to think, and his device will speak for him. And it will sound like him. It will be OG Ken from way back in 2020 before his voice changed.
I'm not certain about whether soulmates exist or not, but if they do, you're mine. I took one look at your dating profile and I was like, wow, hubba hubba. I was smitten.
Ken and I had a whirlwind romance. We met on eHarmony, and we actually texted for 19 hours straight. At the end of that day, he says, you know, can I call you? And when I heard Ken's voice, that was it. It was love at first sound, I guess is kind of the way it is. After we met, we actually started a black car business. He drove people from the airport to meetings. It was at that point where we kind of started noticing things changing.
I noticed that when I tried to pay things up upside down, I would fall over.
It just wasn't normal. And during COVID is when we noticed his voice starting to change. In January of 2024, we received the news that Ken had ALS. I remember feeling
It's
kind
a
of the whole
terrible
weight of the
disease.
world, and it was really scary. I had already lost a husband. I think Ken was worried that he was going to leave me alone again. And that was hard for him.
I like to go out, like to be able to go and do things. I can't even go shopping anymore. And I can't get help. Lots of the time, yes, people don't understand my speech. It's really frustrating.
It's not only just the muscles not working, but it's the fatigue. You don't realize how much energy it takes to talk until you don't have that energy to waste. And it really takes away independence. Our house got really quiet.
Ooh. Many ALS patients lose complete functional speech within 2 to 3 years after symptoms onset.
Our house got really quiet. It's the silence that comes with ALS. Was kind of one of the things I didn't realize when it started was going to be one of the things I noticed the most.
The Neuralink device gives us something that no other device can give us, which is a single neuron recording from thousands of channels simultaneously. The telepathy products is
Like, I bet you in 10 years, maybe 15, might take a little more than 10, people will be cheating in like online multiplayer games because they have a Neuralink, and it's a faster means of communicating, and so they'll cheat in the competitive games. Like, are you using a Neuralink? That'll be one of the things they'll have to deal with in like 15 years.
It's basically recording the neural activity from the small area in the motor cortex that involve in execution of hand and arm movements. But if we go...
So the motor cortex is a better way to do it then. Because I always thought like spine, but I guess that's too much movement, right? You can't put a device there and have it stay perfectly still like you can under your skull, because nothing's moving there, right?
Only about 2 or 3 inches below, there's another brain area that's involved in execution of speech.
That's deep into the brain. Putting something on top of the brain and something in the brain is very different.
First heard about Neuralink online. And when he saw that they had a patient registry open for people with ALS.
I mean, if you're in Canada now, you can look into that, right? I mean, maybe that's worth doing if you have severe... I don't know which one was open. You said that Neuralink was accepting patients from Canada. What kind of patients can apply? Might as well look it up.
He signed up that day.
When you have ALS, you have neuron degeneration, you're unable to transport the signal from your brain to your muscles. It's like a severed internet cable. And with the brain-computer interface, you bypass this pathway completely, and you can read directly from your brain to a device to do the things you want to do.
I mean, look at that.
Like most ALS patients, Kenneth was losing his ability to speak. It was slow, it was tired.
How much time you got to put into training something to get it to read turning a cup? Because like that signal and reading that signal in the brain, like it's an amazing
Tiring and
technology.
difficult,
That is for sure.
and it's something that is progressively getting worse. And so the real value of the brain-computer interface is that it would give Kenneth his voice back. He'd be able to speak comfortably for hours on end by no longer having to speak out loud, but rather just intend to move his mouth silently in a way that's extremely comfortable.
That
He was so excited.
would be difficult.
And I could tell he was excited. I could tell he was a bit nervous.
The only concern I had was the surgery itself. Because my lung capacity is lower. Otherwise, I was going home.
Ken had surgery, and they sent him home the next day. It was such a smooth.
Really? Like brain surgery? I guess if you're putting something on top of the brain. You're not really disturbing the brain. It's just something there that reads the brain. That's crazy. Okay, let's have a look. Good to clarify this because you are really two different bars here. The registry is broad, but the actual trials you'll be screened into are much narrower. For the patient registry itself, the entry requirements are fairly open. You must be 18 years old, meet the age majority in your province or territory, and be a US or Canadian resident. Beyond that, it's open to people with a wide range of neurological and physical conditions. A Canadian applicant needs to have quadriplegic, paraplegic, vision loss, hearing loss, the inability to speak, and or major limb amputation affecting above or below the elbow and above or below the knee. In Alberta, the age of majority is 18, so that threshold is met at 18 for you. It's worth being clear about the registration actually age though. Joining the registry does not enroll you or guarantee enrollment in any future clinical trials, and it isn't even a prerequisite for participating in one. It's a way for Neuralink to collect basic health information and medical records to determine pre-legitimary eligibility for future trials once they become available in Canada. And at the moment, Neuralink does not have any active clinical trials running in Canada. So registry signals interest and gets you into the screening pool. It isn't a path to an implant in the near term. Oh, okay. The actual trials that exist today in the US and device studies generally have much stricter eligibility to be a candidate for the main prime study. The typical criteria are narrower, being at least 19, in some jurisdictions 22, having quadriplegic with no improvement for at least 1 year, and having a consistent caregiver. In practice, the trials target adults with quadriplegia due to spinal cord injuries or ALS that has been stable without improvement for at least a year. There are also exclusions. People with other implanted medical devices, a history of seizures, or a need for regular MRIs are not eligible. You can't have metal in you, right? For an MRI. So that's out. So in short, the registry casts a wide net across paralysis, sensory loss, speech loss, and amputation, but the trials currently being run are focused specifically on people with stable quadriplegia from spinal cord or ALS. The vision, hearing, and speech condition in the registry list apps onto products that aren't yet in human trials. So for those applications are essentially being cataloged for the future rather than enrolled in anything active. So the implanted device reads signals in the motor cortex. Is that then mapped in order to determine how the person would move? And then that translated to a computer. Let's see what it can dig out.
Food process. You would have never known sort of 2 days down the road that anything had ever happened.
Because your brain is just like little electrical signals, right? Being shot off continuously across the brain. And you can measure electrical signals. And so that's what the device with all the little dangly things are. These little nodes that they probably place across your motor cortex or whatever. And then they can read the signals, and these are all the signals from this part of your brain that controls movement. And then you can map that. That's the hard part, though.
We stayed in Dallas for a time after the surgery.
Decoding.
We just did our
it.
Second voice participant surgery last week. Today will be our first day with BCI. We'll go in, show him how to use his charger, how to use his app, and
so it's not a headset. It's a little charger they put beside your brain. So this one, the movement one, is on top, and this one is deeper by the looks of it.
how to use his app, and we will guide him for some sentences to attempt to say, and we'll use that
training data
to try to map neural intent to the actual words.
That's the hard part right there. The mapping, try to get him to say stuff, and then you map that out.
Yes.
I mean, like, if you do this enough times, you could get AI that would be able to figure out and then adjust it really quickly. And it could continuously adjust it rather than just the initial setup.
This is it.
I guess when they still have some speech, it's easier.
Then they have that.
So when a user gets a brain-computer interface, it's sometimes
like he can then not think about saying the words without actually moving to say the words, and then have the computer record that. That is crazy.
It's important for them to play around with their behavior to see what works best. What we did was Kenneth slowed down a little bit and tried to enunciate kind of the individual sounds of his sentence. And really, like, out of nowhere, we went from 0 to 100 with the model.
Really?
Rain in Spain stays mainly on the plane. Ow!
The rain in Spain stays mainly on the plane.
And then it's just like voice stuff, right? Just training a voice model off old voice records to get it to say that.
That's exactly what I said.
Hey.
Come on in.
Oh, nice to see you, Charlie.
Nice to see you guys.
Good morning.
Come on in.
Good morning, Kenneth.
Good to see you.
We're still in an early phase here, but Kenneth is helping us build the future.
We'll start with some data collection just to collect some sentences. After that, we'll train some models and get going.
Yep.
We'll do these at half speed with mouthing and just continue in that direction.
Decoding silent mouth movement.
Siri, turn on lights in every room. I think this is awesome.
The goal is like we want him to be able to simply just intend to move his mouth and for our BCI to decode his speech.
There we go.
I'm talking to you with my mind.
Nice
I
work.
got it.
What was different there?
And that's easing in my head.
Putting more effort in, more intention. It's
Yeah.
modulating your neural signals more.
I am the very model of a modern major general.
Just thinking
Neuralink
really
has
hard
given
about
us
talking.
not only Ken's voice back, but it's really given us a boost. It's given us the chance for Ken
mean,
to
like-
kind of be a pioneer.
Like hope for the future, right? ALS is a gradual decline, usually pretty quick. Doesn't end well, and just he can talk a little now, so you got the model trained, but you'll be able to use this on people that have already like fully lost the voice. To be able to just hear a few words from a loved one can mean so much to people. Man.
What excited me, they fired it up and he told me that he loved me. In OG Ken voice. So emotional for me to hear it the way I heard it on the phone all those years ago. Yeah, something else.
I am finally able to talk to you.
We're going to continue advancing the quality of the sensors, the number of the
This is the worst it'll ever be. Remember that. Like, it'll get better from here.
sensors. We want to build a system that goes directly from the brain to voice in real time. And Kenneth will have instantaneous feedback and control of this voice.
Everyone gets his own color.
Will be blue.
I am going to pay 3 to play Search for Life.
I will take 3.
You're gonna do that?
Yes, please. I'm done with my turn.
Nothing has given me a purpose.
And like the model trained here is what'll be used to advance further, right? Like you are a pioneer in a field of research.
Work together to make this thing better. Maybe I can't cure ALS, but I can participate in research and can give feedback. It will give us back a voice. And the voice is a very important thing to have.
It is.
It would be a total waste of who I am if I didn't do all the good you possibly do. Boy, the more I take out, good to be with the Lord. And that's the number one reason I'm doing this. Because I'm doing good for others. And that is the best thing of all.
You are the captain of your own ship. Make the most of what you're given in life.
I mean, powerful. Yeah, I think this technology is going to come a long way very quickly. I think it has the potential to go a long way yet.